So the toolset itself, let's just take a brief look at that. Comprehensive toolset, it's all task driven, so we need to go and understand how to drive it through those tasks with context sensitive help and the commands that we're working on grouped together. So you'll see the arrow indicator to identify that there's a subset of commands available to you. So in this instance, the simple arc, there's 5 additional commands that are variants on that. But the most complex being, in this instance, arc between elements, and with arc between elements I can achieve all of the other commands that are above it. These toolbars themselves, as we get the flyouts, we can obviously open those as individual toolboxes that are customizable, and so we can create a workflow driven task menu structure if we wanted to assist us in the design process, rather than having to understand and work through our own sort of default workspace. Now those customizable toolbars and customizable commands are an important aspect, and the commands themselves, depending on whether you want to work purely from the panel or adopt a more interactive cursor driven approach, you do have the ability to customize the commands and decide what you see at the cursor prompt, what you're prompted for at the cursor prompt, or whether you just interact in the panel. As novice users, I would suggest you migrate towards the panel and utilize the panel entry, and as you become familiar with the options you will migrate more towards the cursor prompt. But each of these commands is customizable, and you can save the settings and generate your own variation of the commands. So import, export geometry, another important aspect, because we do need to maintain links back to the native product formats. There are some subtle variations between the products with regards to the import. Inroads has an active memory import, and MX has an input file and active model import. All of the native products provide support for land XML and some sort of ASCII file import or tabular editing. So if we have that type of editing that we need to do, or file support from another system, we need to go back to the native products in this instance to deal with those. So I've talked about importing briefly from the native product, and I mentioned about when we may not see the rules active and the manipulators active. That all stems down to civil rules. What do these civil rules mean, and when do they kick in? Well, rule geometry basically gives us those manipulators, the dynamic editing capability. We're promoting that geometry to be edited in the OpenRoads world. If we don't create the civil rules, if we do not engage that tick box on the import geometry, what we'll get is an import representation of the geometry, but we're maintaining control in the legacy product. There are instances where the geometry can't be ruled. We need to understand the recipe behind the construction of that geometry, and sometimes there is geometry that doesn't contain sufficient information to reconstruct it for a dynamic editing capability, and also for certain types of construction and different spiral types that are supported in the legacy products that aren't yet included inside of OpenRoads. So just be aware that sometimes there may be geometry that can't be ruled. If we can't rule it, what does it give us? Well, it gives us geometry that we can use and work with in the DGM. It's still geometry, we can offset from it, we can hang corridors on it, we can modify the station and controls and add station equations. We can override the vertical, give it a new vertical profile. So it gives us the ability to still continue to work and evolve off that design whilst maintaining the horizontal representation that's being controlled by the native product, where we can then re-import it. Exporting the geometry, well, this is the publish for purpose that I mentioned in respect of, instead of auto export, go for a publish for purpose approach. This gives you the choice and control on when you persist back and where you persist it back to. If the geometry has already been persisted, then you'll get a refresh on that, and obviously you'll update the native database. But the native product interacts here and does provide some differences in relation to that persistence and the action of the persistence. And the main example for that being different is the MX model toolbar does have an additional control to decide which model you're persisting back to, as opposed to the active project that you get in Geopack and Inroads.
I'm going to take a look and consider the impact of import geometry and rules. So I'm going to import two pieces of geometry. Mountain Highway, I'll create civil rules for it. This will give me geometry that's editable, provides me a profile that's editable in the dynamic capability of open roads. The second one I'll import without civil rules this time for the pipe road, for the secondary road. I'm going to import that. So now I've got a piece of geometry that is controlled by the native application, and all I can edit in the civil environment are the start station. The same is true for the profile. The profile is controlled in the native product. I can create a secondary alignment profile here if I wanted to, and redefine a profile and set an active profile if I needed to. So with this piece of geometry, if we just create a local corridor, I'll just do it over a short length just to demonstrate. So we now have a profile over the first section of this piece of geometry, which is being driven by the native product. So if we now open Inroads, I'm going to take a look at this piece of geometry, and we'll just edit the curve set over this first range. So if I increase the geometry significantly, we can see it pulls on the inside of the corridor. I now need the corridor to update according to the geometry that's coming from the civil environment. So I can do this by importing that geometry again and triggering an update, and again I'm going to maintain the rules. And so now as I import, it understands it's coming from the same place. It's now updated the geometry, and I've accepted the geometry modifications from the native product. Similarly, with this piece of geometry, we can make modifications and persist. But if we look at this geometry, we can see that we're on the inside because we've made modifications to the geometry. We've changed the geometry. Again, I need to persist this back, and so now I can export this back, and we can review, or we can view, and if I just view it again, it's changed the style, but we've now brought the geometry in line.
So really, when you're considering best practice with regards to import and export geometry, you need to consider where you want to edit that geometry. What's controlling that geometry? What are you going to be doing with that? And think about it. Think about when you're going to use those rules. If it's pre-made geometry that's back in the native product, it can reside there. But obviously, if you're editing in open roads, then you need to have the manipulators available to you. So if you want to promote it up into the open roads environment, do the edits there, that's fine. And then you can adopt this manual export back into the native product to continue your downstream process. But you need to be aware of the impact of editing in the local product, like Inroads, making geometric changes and maintaining synchronization where you've extended on that design and hung corridors off it and so on. So let's take a look at Civil AccuDraw. What is it? Well, Civil AccuDraw basically is just an extension on normal MicroStation AccuDraw that allows us to deal with the constructions that we need and give us this design intent and intelligent updating with open roads. So it's based off MicroStation AccuDraw. It uses some of the similar shortcuts and methodologies with regards to compass, north arrow, and so on. But it gives us the civil context constructions that we need in terms of station and offset and delta stations that we need to build the constructions in the civil world.
So in this instance I'm going to utilize Civil AccuDraw, and as soon as we activate Civil AccuDraw we can see we get some additional prompts. I need to set the origin. What am I coming off relative to? What's the location? And the location is the intersection between those two elements. Now we get dynamic tracking, and I can place a point out in space relative to that junction location. So I can place it back 15 and -6 and accept the point there. At this point in time I'm in a floating origin mode. We can set floating origin mode off and preserve that location. So if I do the same thing again this time and track it back -40, -6, and place a repeater further down. Now the origin is set, so I can come and do further construction should I need to. But the intention here is that we have geometry that is preserved and maintains its rule, so we can make adjustments and it reacts to geometry changes within the model.